So I'm responsible for commercial product development, and it's really and the commercial segment that I deal with is 70 passengers up to the 500 to 600 passengers. So it's really all large commercial airliners. And so my prime responsibility is technology development and readiness, how that interfaces into product development and product configuration or offerings as the airplane companies develop new products for this next generation of aircraft. Well, as you know, the airline industry is under a lot of economic turmoil. Airlines are losing money. There's an overcapacity that's driving low seat cost or low airfares, and there's very high costs, high labor costs, high product acquisition cost, and certainly high fuel price. So as we're looking at the next 2 to 3 years, what industries, the OEMs are trying to do is improve product performance and capabilities like fuel or environmental factors without increasing cost, so we can lower the airline overall operating cost. You're right. I mean, we have made some significant gains over the last 20 years. If you looked at commercial jetliner, passenger jetliner 20 years ago, and the engines that powered that product versus what we've done today, the airplane itself has improved by 20 to 25% in overall fuel efficiency. The bulk of that coming from the engine because of engine efficiency. But and key characteristics are looking for developing technologies that lower weight, improve the power efficiency. We call it the propulsive efficiency of how an engine takes air and fuel and converts that into power. So it can be using new aerodynamic features, using lighter weight materials that have more temperature capability or heat capability, so the engine becomes more efficient as it uses fuel or heat to produce power. And at the same time, looking at emissions, unburned carbon participants or fuel particles that are fuel emissions in terms of how the quality of air that's leaving the engine. So our prime focus over the last 10 or 20 years have been making engines more fuel efficient by making them larger, improving the overall aerodynamics of an engine. Going forward, as we look at future engine features or technologies, it's how do we make a paradigm shift in leveraging technology to create that step function improvement. And one of the areas that I've been involved in over the last several years at Pratt is working what we call a geared architecture that tries to work on some innovative physics to make that step change versus continuing to work and fine-tune, what I'll say, sharpening the pencil to make small incremental improvements. So over the last several years, where Pratt Whitney has really been focusing on is introducing this geared turbofan. And what we do is we introduce a gear between the first compressor that we call a fan and the power turbine that drives that fan. And the key benefit of this introducing this gear is that these fans are quite large. They can be anywhere from 6 to 8 feet in diameter. So they're large, they move a lot of air, and they can also be very heavy because of their size. Now with an introduction of a gear, instead of the fan moving 1 revolution for every revolution in the turbine, we can now have the fan move 1 revolution for every 3 revolutions in the turbine. So we change the paradigm of how the fan is connected to that power turbine. So we can make the fan turn a lot slower now for a given turbine speed. We can improve the efficiency of the turbine by it turning now much faster than what a conventional engine architecture would be. And as we're doing that, we make the efficiency of the engine double-digit better. So where we would normally introduce technology to improve fuel consumption by some amount, by introducing the gear with those same series of technologies, we can almost double the efficiency improvement of the engine for things like fuel consumption, emissions, and even the operating cost or the maintenance cost of keeping that engine in service. It will do, say, 15% reduction in fuel consumption. So it's not half in fuel, but it's a significant amount. Most product improvements from generation to generation improve fuel consumption 5 to 6%. In our next step, with the introduction of a gear, we're doing 12 to 15%. So we basically skip a generation. But the other key factor here is with this gear, because this fan is a key source for engine noise, we drop engine noise 50%, and with combustor technology, we drop emission levels by 50%. So a significant step for this change in, I'll say, overall engine architecture. We're now in product development of our first 2 models that we launched in 2007, and the first will go into service at the end of 2013, and the second will follow just a few months later. So the first product will be on the Bombardier C Series, which is 110 to 150 passenger type aircraft jetliner. And the second model is powering a new regional jet done by Mitsubishi in Japan that will be powering 70 to 90 passengers. And so we're certainly very excited, because this is a major step for the industry in terms of how we're driving our technology to lower, airline operator operating cost. Today we're focusing on a new product. Certainly you could take this technology and retrofit an existing airplane, but from the business economics, that makes it very difficult, because of the amount of cost it takes to develop a product. What really makes most sense is, if you're going to retrofit, is retrofit into an existing airplane that's still in serial production. So that you might do some of the existing fleet, if that makes sense, but more importantly, you're putting it on brand new equipment that's being purchased, so you don't have the cost associated with removing a current engine and then having to modify the aircraft to allow the new engine to be suitable. And sometimes those costs will overpower the fuel efficiency or the value of making the change, because the aircraft already is aged. If you have an automobile that's 10 years old, but you could go put a hybrid engine in it and save a lot of fuel, if you're only going to keep that automobile for 5 years, you'll never get the resale value for making that big a change, that big of investment for changing the engine. But if you've got an automobile like some companies do today that are already in production with gas engines, and now they've introduced that hybrid engine for new automobiles, for new customer purchases, and as you put it into that existing airframe, that's a brand new automobile that's going to be used for the next 15 to 20 years, right? So you get full value of that investment because you're buying it new. So that's how we're trying to leverage this geared technology as to what our next platform, our next business opportunity would be. As I said earlier, the industry, the whole airline industry is struggling because low airfares, high cost, and with some of the economic pressures that the environment's bringing them. Like today we have pretty high surtaxes on airplanes for landing and takeoff for either noise or nitrous oxide. Future, because of all the focus on global warming, many government communities are looking at charging for the amount of carbon emissions. And they're talking, like today, a typical gallon of jet fuel is about $2 a gallon. And as they're looking at what that surtax could be for carbon emissions, they're talking in the order of 30 to 60 cents a gallon as a surtax for operating that equipment in, say, in a given European country. So when you look at that added cost on today's already stressed airline community, it's hard for these companies to compete and still be profitable at the bottom line. So one of the challenges that we have, certainly a company like Pratt Whitney, is as we're bringing technology that typically costs us more, costs a lot to develop, and it costs us more to produce as we're manufacturing our engines, is how do we do that smartly so that as we're offering this new engine or this new product to the airline community, that we're really dropping their overall cost of ownership or operation of our engine. So like with this new geared architecture, if I look at today's workhorse engines that power the 100 to 250 passenger market, as we introduce this new geared engine, we improve fuel consumption 15%, we drop this nitrous oxide by 50%, we drop noise by 50%, and we'll also drop carbon-related emissions by 15 to 20%, because it's, for every gallon of fuel that an engine consumes, it produces 20 pounds of carbon monoxide. So a fairly large influence on the impact on the carbon emissions that one's producing. So as we look at what does this new architecture provide, our target was to lower overall engine operating costs at the airline level by 20%. And today, with the technology work that we've done in the engine demonstrator that we just completed, we're approaching actually 25% cost reduction. So that's the challenge that we have as an OEM, to really drive value to our end customer. We're selling worldwide. We're selling right now. We're on two platforms that Bombardier and Mitsubishi are actively campaigning or marketing their equipment. And we hope that within the next several years, the two major OEMs, Airbus and Boeing, will also be pursuing new product, and gives us an opportunity to leverage our new geared architecture on those platforms. Certainly the focus on global warming and this surtax or surcharge for the amount of carbons that an airline operator will emit in that country, that's a key element. And I think the other element is the uncertainty in what's the cost of fuel. Today it's in that $2 to $2.50 per gallon. Not that long ago, about 15 months ago or 18 months ago, we were at $3.50 a gallon. So the real question becomes, as fuel starts to creep above, $100 a barrel or $150 a barrel, that has a very significant impact on airline operating cost.